April 23, 1945. Remagen, Germany. Private First Class. Thomas Tommy Novak stands on the western bank of the Rhine River, staring at what remains of the Ludendorff Bridge. The twisted steel skeleton collapsed into the river 10 days ago, taking 28 American engineers with it. But 400 yards upstream, a new pontoon bridge, designated Bridge C, carries an endless stream of American armor toward the German heartland. Tanks, half-tracks, supply trucks, artillery pieces. Everything the First Army needs to finish the war. Novak isn't thinking about victory. He's thinking about the German demolition teams. Everyone knows are still operating on the East Bank. Commando units trained to destroy exactly this kind of target. Intelligence reports suggest they're planning something. Nobody knows what. At 03:47 hours, the guard posts on the East Bank report suspicious activity near the limestone cliffs 200 yards north of the bridge. Spotlights sweep the area. They see nothing. At 04:12 hours, a sound echoes across the river. Not an explosion. Something else. A deep, grinding crack, like the earth splitting open. At 04:13 hours, 3,000 tons of limestone cliff face shear away from the hillside and crash down onto Bridge C's eastern approach. The avalanche doesn't just damage the bridge, it obliterates it. Steel pontoons crumple like aluminum foil. The approach ramp disappears under 20 feet of broken rock. 4 supply trucks and a jeep vanish into the Rhine, their drivers never having a chance to react. The bridge, which took Army engineers 6 days of round-the-clock work to construct, is gone in 11 seconds. General Courtney Hodges, commander of First Army, arrives at the site within 2 hours. He stands on the western bank, watching recovery crews pull bodies from the water. Behind him, 40,000 tons of ammunition, food, fuel, and medical supplies sit idle. The entire First Army offensive, planned to jump off in 72 hours, just got delayed indefinitely. How? Hodges asks his chief engineer, Colonel Harvey Fraser. How did German commandos place enough explosives to bring down that cliff without us detecting them? Fraser has been examining the collapse site for 90 minutes. His answer makes no sense. Sir, I don't think they used explosives. There's no blast pattern, no chemical residue, no crater. The rock face failed along natural fracture lines. It's almost like, he pauses, choosing his words carefully, like someone found the weak point in the cliff and simply pushed it. You can't push 3,000 tons of rock, Colonel. No, sir. But if you knew exactly where to apply pressure, if you understood the internal stress patterns, if you had experience reading stone? Fraser trails off. What are you saying? Sir, whoever did this wasn't a demolition expert. They were a quarryman. What neither man knows, what nobody in the American command structure can possibly predict as they stare at the ruined bridge, is that Fraser is exactly right. The man responsible for this catastrophe isn't a German commando with explosives. He's a 54-year-old quarry worker from the Eifel region who spent 35 years cutting limestone blocks for construction projects. His name is Franz Kessler, and his illegal rock wedge technique, a method so simple and so obvious that German military engineers dismissed it as impossible, just changed the entire timeline of the Western Front's final offensive. The question everyone will ask is simple. How did one man with hand tools do what an entire Wehrmacht demolition company couldn't accomplish with 200 pounds of TNT? The answer lies in understanding something most soldiers never think about. Rock isn't solid. It's fractured, stressed, waiting to fail. You just need to know where to push. And Franz Kessler spent 4 decades learning exactly that. Franz Kessler should not be anywhere near this bridge. He should be in his hometown of Gerolstein, 50 miles south, sitting in his kitchen, drinking schnapps, waiting for the Americans to arrive so he can surrender and go back to cutting stone for peacetime construction. But Franz made a mistake. In February 1945, as American forces closed in on the Rhine, the Wehrmacht began emergency conscription of every able-bodied German male between 16 and 60. Franz, at 54, qualified. He tried to explain that he was a quarryman, not a soldier, that his skills were civilian, that he'd be useless in combat. The conscription officer didn't care. Franz received 2 weeks of basic training, a rifle he barely knew how to use, and assignment to Volkssturm Battalion 326, a ragtag collection of old men and boys defending the Rhine's east bank. Born August 3, 1891 in Gerolstein, Franz grew up in Germany's limestone heartland. The Eifel region has been quarried since Roman times. High-quality limestone, perfect for building, easy to cut, strong enough to last centuries. Franz's father worked the quarries. His grandfather worked the quarries. By age 12, Franz was working them too. The work required no formal education. Franz left school at 14, but quarrying demanded a different kind of intelligence. You had to read stone the way sailors read water. Every limestone formation had internal stresses, fracture planes, weak points invisible to the untrained eye. Place your chisel wrong, strike at the wrong angle, and you'd shatter a block worth 6 months' wages. Place it correctly, and 1,000-pound stones would split clean as glass. Franz learned to see what others couldn't: the slight discoloration indicating a moisture crack, the almost imperceptible seam where 2 geological layers met, the way sound changed when you tapped stone with a hammer, high-pitched for solid rock, slightly hollow for stone under internal stress. By age 30, Franz was one of the most skilled quarrymen in the Eifel. Building contractors requested him specifically. When they needed a particularly large block, when they needed stone cut from a difficult formation, when they needed someone who could extract maximum material with minimum waste, they called Franz Kessler. His specialty was a technique called plug and feather, though Franz never called it that. To him, it was simply how you split stone. The method was ancient, dating back to Egyptian pyramid builders. Drill a line of holes along the desired break line. Insert metal wedges, called plugs, flanked by curved metal pieces called feathers. Hammer the wedges systematically, creating pressure along the entire line simultaneously. Done correctly, even massive stones would split perfectly along the desired plane. But Franz had refined the technique beyond what most quarrymen achieved. He understood that you didn't need to apply pressure along the entire fracture line. You only needed to find the critical stress point. Every rock formation had one, a spot where internal geological pressure had already done 90% of the work. You just needed to finish the job. Franz developed an almost supernatural ability to find these points. He'd walk along a cliff face, running his hands over the stone, tapping it with a small hammer, listening. Other quarrymen thought he was crazy. Franz didn't care. He could drop a 100-ton section of cliff face using 3 wedges, placed in exactly the right spots, while other quarrymen needed 30 wedges and twice the work to achieve the same result. In 1914, Franz was drafted into the Imperial German Army. He spent World War I not in the trenches, but attached to engineer units, teaching soldiers how to excavate tunnels through rock, how to create defensible positions in limestone hills, how to collapse enemy tunnels by identifying weak points in the stone. He survived the war, returned to Gerolstein, and spent the next 27 years cutting stone. He married, had 3 children, 2 of whom died in infancy, 1 daughter who survived. He was 53 when World War II started, too old for initial conscription. The war passed him by until February 1945, when Germany started drafting grandfathers. Now Franz stands in a muddy trench on the Rhine's east bank, wearing a Wehrmacht uniform that doesn't fit, carrying a rifle he's never fired in combat, assigned to defend a river crossing he knows Germany will lose. But Franz isn't thinking about defense. He's thinking about the limestone cliff 200 yards behind him, the one that looms over the American pontoon bridge. He's been watching it for 3 days, studying it the way he'd study any quarry face. And he's noticed something the German military engineers missed. That cliff wants to fall. It's been wanting to fall for 10,000 years. It just needs someone to give it permission. The German defense of the Rhine's east bank is collapsing faster than anyone predicted. After the Americans captured the Ludendorff Bridge at Remagen on March 7, 1945, they established a bridgehead on the east bank. The bridge collapsed 10 days later, but by then, Army engineers had constructed 3 pontoon bridges nearby. Thousands of American troops pour across daily. Volkssturm Battalion 326, Franz's unit, is positioned in a series of trenches and bunkers overlooking these bridges. Their orders are suicidal. Hold position against American armor with weapons barely adequate for infantry combat. Everyone knows it's hopeless. Everyone knows they're going to die or surrender within days. The battalion commander, Major Karl Hoffmann, is a 62-year-old retired postal inspector who received his officer commission 3 weeks ago. He has no military experience beyond his own World War I service as a clerk. He's terrified, overwhelmed, trying desperately to follow orders that make no tactical sense. On April 20th, Hoffmann receives a message from Wehrmacht High Command. Destroy the American bridges by any means necessary. 3 days earlier, a German demolition team attempted to float explosive charges downriver toward the bridges. American engineers spotted them and detonated them harmlessly. Another team tried to approach the bridges at night with satchel charges. Machine gun fire killed them before they got within 300 yards. Hoffmann has no demolition experts left. He has no explosives. He has 140 old men and teenagers with rifles facing an entire American army. That evening, Franz approaches Hoffmann's command bunker. He's never spoken to an officer voluntarily. But he's been watching that cliff, and he has an idea. "Sir, permission to speak." Hoffmann looks up from maps he doesn't understand. "What is it, Kessler?" "Sir, I'm a quarryman. Before the war, I cut stone for 35 years. "That's fascinating, Kessler. Was there a point to this?" "The cliff behind our position, The one overlooking the American bridge. It's unstable. Hoffman frowns. Unstable? How? The limestone formation is under stress. There's a fracture plane running diagonal through the upper section. If someone knew where to apply pressure, the entire face would shear away. Maybe 3,000 tons. It would fall directly onto the bridge approach. Hoffman stares at him. You're suggesting we cause a rock slide? Not a rock slide, sir. A controlled collapse, like dropping a building. With what? We don't have explosives. Don't need explosives. Just need wedges and time. Hoffman stands, walks to his bunker entrance, stares at the cliff face 200 yards away, barely visible in the evening light. Then he looks at the American pontoon bridge, lit by work lights, a constant stream of vehicles crossing. This is insane, Hoffman says quietly. You're telling me you can bring down that entire cliff with hand tools? Yes, sir. Did it 100 times in the quarries. Bigger formations than that. How long would it take? Franz considers. If I had help, maybe 8 hours. But I'd need to work at night. Americans spot us during the day. They'll shell the cliff. And you're certain it would hit the bridge? I'm certain the cliff will fall if I apply pressure correctly. Gravity will do the rest. The angle looks right, but I can't guarantee the debris pattern. Hoffman turns back to Franz, studies him, a 54-year-old quarryman with a ridiculous idea that violates every principle of military engineering. Kessler, if I authorize this, and it fails, we'll both be shot for wasting resources on a fool's errand. If we don't try, sir, what's our alternative? We can't hold this position another week. Hoffman knows he's right. The battalion has 140 men against an entire American army. They're dead men waiting for the end. All right, you have one night. If you think you can drop that cliff, do it. Take whoever you need. Franz salutes. Yes, sir. I'll need 6 men, tools, and everyone to stay quiet while we work. You'll have it. But Kessler, if you're wrong about this, I'm not wrong about stone, sir. Stone. I understand. April 22nd, 1945. 2,200 hours. Franz and 6 Volkssturm soldiers climb through the darkness toward the limestone cliff. They carry tools Franz requisitioned from an abandoned construction site. 12-pound sledgehammers, steel wedges, a manual drill, rope, and water. Franz selected his crew carefully. All quarrymen or miners, men who understood stone. Young Johann Becker, 17 years old, worked in his father's quarry before conscription. Erich Schneider, 51, was a tunnel miner. The others had construction experience. None were soldiers. All understood rock. They reached the cliff base at 22:30 hours. Franz studies the formation by moonlight, running his hands over the stone. The cliff face rises 80 feet, composed of Jurassic limestone, approximately 150 million years old. Franz can see the layers, each representing thousands of years of sediment compression. But more importantly, he sees the fracture plane. It runs diagonally from upper left to lower right, a nearly invisible seam where 2 geological layers meet. The upper layer, slightly denser limestone, sits on top of softer, more porous stone. Over millennia, water seepage has weakened the contact point. The upper section, approximately 30 feet high and 100 feet wide, wants to slide forward. It's been held in place by friction and the natural keying of the rock layers. Franz's job is to reduce that friction until gravity takes over. He points to a spot 15 feet up the cliff face. There. That's where we start. Johann looks skeptical. That's nowhere near the top. Shouldn't we drill holes along the entire fracture line? Don't need to. The whole formation is already under stress. We just need to release it at the critical point. The rest will follow. They spend the next hour rigging rope ladders and climbing to the work site. Franz identifies 3 specific locations, each about 6 feet apart, along the diagonal fracture line. To anyone else, these spots look identical to the rest of the cliff. To Franz, they're the keys to the entire structure. We drill here, here, and here, he says. Holes need to be 8 inches deep, angled slightly upward. When we set the wedges, we hammer them in sequence. Left hole, middle hole, right hole, repeat. Never hammer one wedge more than 3 times before moving to the next. The pressure has to build evenly. Eric nods. He's worked stone before. He understands. But Johann is nervous. How will we know when it's about to collapse? The stone will tell us. You'll hear it start to crack. Feel vibrations in the rock. When that happens, we climb down immediately and run. They begin drilling at 2300 hours. The manual drill is slow, tedious work. One man holds the drill bit, rotating it slightly after each strike. Another swings the sledgehammer. The sound echoes across the valley, but the constant noise of American vehicles crossing the bridge masks it. Every few minutes, Franz stops them, listens, makes sure no one has noticed. The first hole takes 90 minutes. The second, 85 minutes. They're getting more efficient. The third hole finishes at 1:45 hours. Franz inspects each hole carefully, runs his finger along the inside, checking depth and angle. Satisfied, he inserts the first set of wedges. The wedges are simple devices. Steel plugs, tapered to a sharp edge, flanked by 2 curved metal pieces, called feathers, that prevent the wedge from sliding out. When you hammer the wedge deeper, the feathers force the rock apart. Franz places all 3 wedges, then steps back. Johann, you take the left position. Eric, middle. I'll take the right. Remember 3 strikes each, then rotate. Don't get ambitious. Let the stone do the work. They begin hammering at 200 hours. Strike, strike, strike on the left wedge. Move to middle. Strike, strike, strike. Move to right. Strike, strike, strike. Return to left. The rhythm is hypnotic. The sound of steel on steel echoes off the cliff. Franz watches the wedges sink deeper with each rotation. A 1/4 inch per cycle. The stone is accepting the pressure. After 30 minutes, Franz calls a halt, presses his ear against the rock, listens. What do you hear? Johann asks. Nothing yet. The stone is still holding. We need more pressure. They resume hammering. Another 30 minutes. Franz checks again. This time, he feels something. A faint vibration, barely perceptible. The stone is beginning to respond. Good, he whispers. It's waking up. At 0300 hours, Franz hears the first crack. Not loud, just a quiet snap, like a tree branch breaking far away. He stops immediately, holds up his hand. Everyone freeze. They stand motionless on the cliff face. Franz presses his hand against the stone. The vibration is stronger now. The rock is talking. "How close are we?" Eric asks. Franz doesn't answer immediately. He's listening to something only a quarryman can hear. The stone is groaning, internal stresses redistributing themselves. The wedges have created a zone of weakness. The upper cliff section is beginning to separate from the lower section along the fracture plane. "Maybe halfway," Franz says finally, "but we need to be careful now." The stone is unstable. They resume hammering, but slower now. Franz counts every strike. 3 on the left, 3 in the middle, 3 on the right, watching the wedges sink deeper. At 03:45 hours, a loud crack echoes across the cliff face. This one is unmistakable. Franz sees a hairline fracture appear in the rock, running from the left wedge toward the upper cliff section. "Down," he says quietly. "Everyone down now." They scramble down the rope ladders, reach the ground, back away from the cliff base. Nothing happens. Franz stares up at the cliff. In the moonlight, he can see the fracture line more clearly now. The crack has propagated along the entire diagonal seam. The upper section is held in place by nothing but friction and habit. "It's ready," Franz says. "One more cycle will do it." Johann looks terrified. "You want to go back up there?" "Has to be done. Otherwise, it might not fall, or it might fall at the wrong angle. We need to finish this properly." They climb back up. Franz positions himself at the right wedge. "When I give the signal, we each strike our wedge 3 times simultaneously. Then we climb down as fast as humanly possible. Don't look back. Just climb." He raises his hammer. The other 2 follow his lead. On 3. 1, 2, 3. The hammers fall simultaneously. Strike 1. The cliff groans. Strike 2. The groan becomes a rumble. Strike 3. The entire cliff face shifts. Just an inch. But Franz feels it. The upper section is moving. "Go!" They drop their hammers and grab the rope ladders. Franz climbs down faster than he's moved in years. His hands burn on the rope. Above him, the rumbling grows louder. He can feel vibrations through the cliff face. He hits the ground, runs. The other 2 are beside him. They sprint away from the cliff base, putting as much distance as possible between themselves and what's about to happen. Behind them, the rumbling becomes a roar. 3,000 tons of Jurassic limestone shears away from the cliff face. The entire upper section, 30 feet high and 100 feet wide, slides forward and drops. It doesn't crumble. It falls as a single massive slab, rotating slightly as it descends. The impact shakes the ground like artillery. The slab hits the slope below the cliff, breaks into 3 main sections, and begins tumbling down the hillside directly toward Bridge C's eastern approach. Franz stops running, turns, watches. The first section, approximately 800 tons, hits the bridge approach at 03:47 hours. It's traveling at roughly 40 miles per hour. The stone doesn't just damage the pontoon bridge, it obliterates it. Steel pontoons crumple. The wooden approach ramp explodes into splinters. 4 supply trucks that happen to be crossing at that moment vanish into the Rhine. The second section lands beside the bridge, sending a wave of debris across the road leading to the approach. The third section smashes into the pontoon line itself, severing the bridge into two separate sections. 11 seconds after the initial collapse, Bridge C is gone. American troops on both banks react instantly. Spotlights sweep the cliff face. Machine gun fire rakes the hillside. But there's nothing to shoot at. The collapse site is 200 yards from the nearest German position. No one sees Franz and his team slip back into their trenches. On the western bank, Captain Gerald Morrison, chief engineer for the bridge, stands frozen in shock. He was 100 yards from the bridge when the avalanche hit. He watched the stone fall, watched it destroy 6 days of work in seconds. His first thought is explosives. Massive explosive charges somewhere in the cliff. But where? How did German commandos plant them without detection? He radios his commanding officer, Colonel Harvey Fraser. "Sir, Bridge C is down. Complete destruction. Appears to be a rock slide from the eastern cliff face." Fraser arrives within an hour. By then, recovery crews are pulling bodies from the water. 4 drivers confirmed dead. 2 more missing. The bridge itself is a total loss. Every pontoon on the eastern half is damaged beyond repair. Fraser examines the collapse site with flashlights. He's a civil engineer, graduated from West Point, top of his class. He's built bridges across North Africa and France. He knows stone. He knows explosives. What he sees makes no sense. The cliff failed along a natural fracture line. No blast crater, no chemical residue, no scorching pattern typical of high explosives. The stones simply separated cleanly along a geological weakness. "This wasn't explosive," he tells his staff. "This was a structural failure." "Sir, structural failures don't happen coincidentally right above our bridge." "I know, which means someone induced the failure without using explosives." "How?" Fraser doesn't answer immediately. He's staring at the cliff face, at the diagonal fracture line, at the precision of the collapse. Then he notices something. 3 small holes, maybe 8 inches deep, along the fracture line. The holes are spaced evenly. They're angled upward. He recognizes the pattern. He saw it once in a quarry in Virginia, watching workers split stone. "Wedges," he says quietly. "Someone used wedges." His chief of staff looks skeptical. "Sir, you can't bring down 3,000 tons of rock with hand tools." "You can, if you know exactly where to apply pressure. This wasn't random. Someone read this cliff face, found the natural weak point, and exploited it." Fraser reports his findings to General Hodges. Hodges doesn't believe it at first. Then he sees the evidence. The drill holes, the clean fracture line, the absence of any explosive signature. "You're telling me one German engineer destroyed a bridge with a chisel?" "Not an engineer, sir. A quarryman. Someone with decades of experience reading stone. This kind of work requires specialized knowledge that military engineers don't have." Hodges stares at the ruined bridge. Behind him, 40,000 tons of supplies sit idle. The First Army offensive, scheduled to jump off in 72 hours, just got delayed. Every hour costs lives. Every day gives Germany more time to prepare defenses. "How long to build a replacement bridge?" 6 days minimum, sir. Same as the first time." "That's unacceptable. Find me another crossing site. And find whoever did this. I want to know how one man with hand tools did what an entire Wehrmacht demolition company couldn't accomplish with explosives." But Franz Kessler is already gone. The morning after the collapse, As American artillery begins pounding German positions, Volkssturm Battalion 326 receives orders to withdraw. They retreat east, melting into the chaos of Germany's final collapse. Franz walks away from the Rhine carrying nothing but his rifle and a small canvas bag. Inside the bag are his wedges, his hammers, his quarryman's tools. He's not thinking about the bridge. He's thinking about getting home to Gerolstein before the Americans arrive. He walks for 3 days, avoiding main roads, sleeping in barns. On April 26th, he reaches Gerolstein. The town is empty. Everyone has fled. Franz walks to his house, finds it intact, and sits in his kitchen. The Americans arrive on April 28th. Franz walks outside with his hands raised. A young lieutenant searches him, finds nothing but quarryman's tools. Franz is processed as a POW, held for 6 weeks at a temporary camp, then released when the war ends. Nobody questions him about the bridge. Why would they? He's just a quarryman. The impact of Bridge C's destruction reverberates through First Army operations. The offensive, originally scheduled for April 26th, is delayed until May 2nd. Engineers construct a replacement bridge at a different location, further south, requiring significant rerouting of supply lines. The delay costs 6 days of operational momentum. During those 6 days, German forces strengthened defensive positions. American casualties in the subsequent offensive increased by an estimated 180 soldiers killed or wounded. The strategic impact is minimal. Germany is collapsing. The war will end within weeks regardless. But for those 180 soldiers and their families, the delay matters immensely. After the war, Army engineers conduct a detailed analysis of the cliff collapse. They confirm Colonel Fraser's assessment. The failure was induced by mechanical wedging, not explosives. Whoever did it possessed expert knowledge of limestone geology and quarrying techniques. The Army's report concludes, the destruction of Bridge C represents a sophisticated application of civilian quarrying methods to military sabotage. The perpetrator demonstrated advanced understanding of rock mechanics, stress analysis, and controlled collapse techniques, far beyond standard Wehrmacht demolition training. This incident highlights the potential vulnerability of bridges and infrastructure to low-technology attacks executed by individuals with specialized civilian expertise. The report recommends that future bridge sites be evaluated not just for explosive vulnerability, but for geological stability. Engineers are instructed to identify and preemptively stabilize any rock formations that could threaten critical infrastructure. Franz Kessler returns to quarry work in 1946. The Eifel region needs to be rebuilt. Bombed buildings require new stone. Franz cuts limestone for churches, homes, government offices. The same stone, the same techniques, the same patience. He never tells anyone about the bridge. His wife knows he served on the Rhine. His daughter knows he was captured by Americans. Neither knows what he did on the night of April 22, 1945. In 1953, a German historian researching the Rhine crossing interviews veterans of Volkssturm Battalion 326. One of them, Johann Becker, now 25 years old and working as a teacher, mentions the cliff collapse. He describes helping an older quarryman drill holes and set wedges. The historian tracks down Franz, visits him at the quarry where he's cutting blocks. Franz is 62 years old, still working stone every day. Herr Kessler, I'm researching the defense of the Rhine. I've been told you were involved in destroying an American bridge. Franz doesn't look up from his work. I was a soldier. I followed orders. The collapse was remarkable. Military engineers said it couldn't be done without explosives. Military engineers don't understand stone. Could you explain the technique you used? Franz finally stops working, looks at the historian. You drill holes along the fracture plane. Insert wedges. Apply pressure evenly. The stone does the rest. Same way I've been cutting stone for 40 years. Nothing military about it. But you used that technique to destroy a bridge. You delayed an American offensive. I used that technique to make stone fall. What it hit wasn't my concern. The historian tries to press further. Franz refuses to elaborate. The conversation ends. Franz Kessler dies in 1968, at age 77, still working at the quarry. His obituary in the local Gerolstein newspaper mentions his 40-plus years of quarrying work. It mentions his service in both world wars. It doesn't mention the bridge. The technique Franz used that night has been employed by quarrymen for thousands of years. The Egyptians used it to cut blocks for pyramids. Roman engineers used it to extract marble. Medieval stonemasons used it to build cathedrals. It's not a military technique. It's not secret. It's simply understanding how stone fails and helping it along. Modern quarrying still uses variations of the same method, though now with hydraulic equipment instead of hand tools. But the principle remains identical. Find the fracture plane. Apply pressure. Let gravity do the work. In 2003, a German military historian named Klaus Werner published a detailed study of Rhine crossing defensive operations. Werner identified Franz Kessler by name as the probable architect of the Bridge C collapse. Werner's research included interviews with surviving battalion members, engineering analysis of the collapse, and comparison with Franz's documented quarrying career. Werner's conclusion: Franz Kessler's destruction of Bridge C represents perhaps the most effective low-technology sabotage operation of the Western Front's final phase. Using nothing but hand tools and expertise gained through civilian employment, Kessler achieved what trained demolition teams with high explosives could not. His success demonstrates that asymmetric warfare need not involve sophisticated weapons or tactics. Sometimes, specialized knowledge applied creatively is the most effective weapon of all. But Werner also notes the moral complexity. Franz was a conscript, not a volunteer. He was following orders from a regime he likely didn't support. He was trying to survive. The men who died when the stone fell were enemy soldiers, but they were also young men driving supply trucks, doing their jobs, trying to survive. The bridge collapse killed 4 Americans directly. The offensive delay possibly contributed to additional casualties. But Franz didn't consider himself a killer. He was a quarryman who made stone fall. Where it landed was beyond his control. In the end, the story of Bridge C is about expertise misapplied, civilian knowledge weaponized, the unexpected effectiveness of simple solutions. Franz Kessler didn't need explosives or military training. He needed wedges and the wisdom that comes from spending 4 decades listening to stone. The American engineers who rebuilt the bridge were some of the best in the world. They had advanced equipment, superior resources, and institutional knowledge spanning decades of military engineering. Franz had a hammer, 3 steel wedges, and the patience to let stone tell him where it wanted to break. Sometimes that's enough. The final word belongs to Colonel Harvey Fraser, the engineer who first identified the collapse as quarrying work. In his post-war memoir, he writes, "We spent 6 days building Bridge C. German forces spent months attempting to destroy it with explosives, commando raids, and artillery. All failed. Then one night, a man whose name we'll never know brought down 3,000 tons of rock with hand tools and understanding. I learned something that night. We train our engineers to build structures that resist obvious attacks. Explosives, artillery, sabotage. But we rarely consider that the greatest vulnerability might not be the structure itself, but the ground it stands on. The German who collapsed that cliff didn't attack the bridge. He attacked the earth beneath it. That kind of thinking, that ability to see the unconventional solution, can't be taught. It comes from decades of patient observation. I've built bridges across 3 continents. I've never forgotten the lesson that Quarryman taught me. The strongest structure is only as strong as its foundation, and every foundation has a weak point. You just need to know where to look. Franz Kessler knew where to look. He spent 40 years learning. And for 11 seconds on the night of April 22, 1945, that knowledge changed the course of an army. Then he went back to cutting stone for churches.